Hello dear viewers. In this video, I'm going to explain assertion and reason-based questions for class 10, and these are picked from chapter 1 to chapter 7. There are total 30 questions, and in this video, I'm going to explain from question number 1 to 5. So as we know, in assertion and reason, we got 4 options. Here the first option is both A and R are true and R is the correct explanation of A. B option, both A and R are true but R is not the correct explanation of A. Next is A is true but R is false. The other one is A is false but R is true. So let's start the question now. Question number 1. Question number 1 is assertion LCM and HCF of A and 20 are 100 and 10 respectively, then A is equal to 50. So we are going to simplify this. LCM and HCF of A and 20 are 100. LCM A and 20 is 100 and HCF of A and 20 is 10. So now just simplify this. As we know, LCM into HCF is equal to product of the two numbers. Product of two numbers. So we can take LCM is 100, HCF is 10 is equal to product of two numbers. The two numbers are A and 20. So on simplifying these, we'll get 100 is equal to 2 of A and A will be 100 by 2. So this is 50. Here what we get? A is equal to 50 as it told in the assertion. Now we'll check the reason. Reason is saying LCM into HCF is equal to first number into second number. So we all know that this property is true. So reason is true and assertion is true, and we can see if we connect them that reason is the correct explanation of assertion. So here our answer is A option. Both A and R are true and R is the correct explanation of A. Now question number 2. Assertion is HCF of smallest prime and smallest composite number is 2. So if we take smallest prime number, we all know that is 2, and the smallest composite number, that is 4. Because 1 is neither prime nor composite, 2 is the prime number, 3 is again the prime number, and 4 is the composite number because the factors of 4 are 1, 2 and 4. And when we take the HCF, we'll get the factor of 2 is 2 into 1. Factor of 4 is 2 into 2. And the HCF will be the common number. HCF is 2. So here you can see that this statement is true. Now the reason is smallest prime is 2 and smallest composite is 4. Yes, we know that smallest prime is 2. This is true. Smallest composite is 4. So their HCF is 2. Yes, we have done this in assertion in this part. So we can say this is true. So here we can say A and R are true, and again both A and R are the true, and R is the correct explanation of A. So here the answer will be option A. Answer is option A. Question 3, assertion A is 2 is a rational number. So we all know that 2 is a rational number because 2 can be written in the form of 2 by 1, P by Q, and here Q is not equal to 0. So this we can say this is true. And the reason R is square root of all positive integers are irrational. So let's say any square root, any number of square root, let's say this is 4, and the square root of 4 is 2. But you can see that 2 is not irrational. 2 is rational as we said above, and that is true. So here reason is false and assertion is true. So the option will be A is true but R is false. So C option is the answer. Answer is option C. Question 4. If P is a prime number and then HCF of P, P square and P cube is P. So let's check it. P is a prime number and there are three numbers P. The factor of P will be P into 1 because P is prime. Factor of P square will be P into P. Factor of P cube will be P into P into P. So here you can see the HCF will be P. HCF is P. So here you can say that the assertion is true. Now reason, HCF of 3 number is smallest number among them. So we need to take one example here. Let's say the 3 numbers are 3, 4 and 12. So as per the statement of reason, the HCF should be 3. Now let's check it. Factor of 3 are 3 into 1. Factor of 4 are 2 into 2. And factor of 12 are 2 into 2, 2 to the 4 into 3. So here you can see that no common factor is there. And we can say HCF is equal to 1 only. So here we can say that reason is false. Now the conclusion is assertion is true but the reason is false. So there will be again option C answer. Answer is option C. Now, question number 5 is assertion square root A is an irrational number where A is a prime number. So if we take examples, we can say prime number is 2. Yes, this is an irrational number. 3 is prime. 7, 11, 19 up to so on. So here we can see that if A is a prime number, then square root A will be an irrational number. And we can conclude that assertion is true. Now reason says square root of any prime number is an irrational number. So square root of any prime number, we have taken the example above. Same way we can take here square root of any prime number. You can check for other numbers. So that is an irrational number. Yes, this is true. And so our answer will be assertion is true and reason is also true. So reason can be the correct explanation of A. So our answer is option A. Thank you so much for today.